Adding and subtracting fractions. What do we have to have first? We have common denominator. What's the common denominator between 5 and 6? 30? Yeah, 30. Okay. 5 times what gets me 30? 6, which means I got to multiply the top by 6. 6 times 2 is, well, 6 times what is 30? 5. Means I got to multiply the top by 5. 1 times 5 is 5. Okay, so I got common denominators. I've adjusted my fractions. Now what do we do? Subtract numerators. What about the denominator? Stays at 30. Okay. 12 minus 5 is 12 minus 5 is 7. Can 7/30ths be reduced? Nope. What does it say to evaluate 2/3 times the quantity x plus 5 when x equals 4? What do we do there? We change x to 4 and then we just do the math, right? So we're going to take this 4, and we're going to put it in right there, right? Okay? 4 plus 5. 4 plus 5. Trying to find something that I can throw to wake you guys up. No, I need something loud. I don't have a decimal speak, so I'm not going to read it. What? No, it's way over there. Yeah. Wake up, people! Okay? Right? Right? Hats should be off, hoods should be down, earbuds should be out, phones should be away. Let's go! 4 plus 5. This is an easy one. 9. What? Jake, not today. You know what I mean? I mean, there's a time for it, don't get me wrong. I think sometimes you're hilarious. But right now is not one of those times. Okay? Not after I just got done yelling at him to wake up. Okay? I know. You took your hat off. Okay? 2/3 times 9. Put 9 over 1. Okay? Then what? 2 times 9 is 18. And then what? 3 times 1 is 3. Can 18 be divided by 3? Yeah, how many times? 6. So my answer is just 6. It's kind of like that check step, right? So we have done the check. I don't know how to check it. No. Right? Let's do this. One more time, for old time's sake. And we'll probably do it again tomorrow, or not tomorrow, Monday again, too. Okay? Step number 1 is what? We distribute. What do we do? What's the purpose, Nora, of distributing? To clear parentheses. Yep, exactly. So step number 1, we distribute, and the reason that we distribute is to clear or get rid of any and all parentheses. Okay? Step number 2, we want to clear our fractions. How do we go about clearing our fractions? Go ahead. common denominator, so we're going to multiply each term. And why do we do this? Why do we clear our fractions out of it? Anybody remember why we clear our fractions out of there? I said it a couple of times. Not to get the x by itself. That's what those bottom two are for. Makes it easier. Okay? It just makes the problem easier. Because now you don't have to pick common denominators to add, subtract fractions and all that stuff. Okay? It just makes the problem easier. So if you multiply and you clear your fractions, it's fine. You don't have to do that one. You can do it without clearing your fractions. You just got to do more math. Okay? Step number 3. Combine like terms. Okay? And why do we do that? Nope. Still not there yet. What is that? That's what makes like terms like, right? You gotta have the same exponents and they gotta have the same variables. But why do we combine them? Yeah, it shrinks our equation and makes it easier for us. Okay? Steps 2 and 3 are there to make it easier on you. Okay? That's what those two are there for. Okay? And then we've got our add and subtract and multiply and dividing. Okay? And why do we do this? Nora, I'm going to give this one to you now. Why do we do this? Variable by itself. Okay? Because that's how we go about solving. Okay? Yeah? Do number 1. Stick with me today. You got to hang with me today. Okay? Don't try and work ahead today. You got to hang. Okay? Okay? So let's do number 1. Number 1, step 1 says, do we have any parentheses that we need to clear? Yeah? Okay? So what am I going to do now? Distribute what? The 2. I'm going to take this positive 2 and I'm going to distribute it into the x, and I'm going to distribute it into the negative 5. Okay? So that's going to give me 3, then 1. Plus 2x, then 1. Minus 10, and that's going to equal 2x plus 2. Okay. Step number 2 says we need to clear any fractions. Brock, do we have any fractions that we need to clear? No, so step 2 is done. Not always are we going to have to do step number 2. Right? Not always, likewise, not always are we going to have a parentheses that we're going to need to clear up. Step number 3, combining some like terms. Alex, have you got any like terms that we can combine on either the left or the right side? Yeah. What do we got? Yeah. Okay, what are those combined to be? Nice job, good job. Yep, exactly. Those 2 right here, these 2 right here, we'll put them in the blue. These 2 right there combine to give me negative 7. Okay. All right. Any more like terms to combine? No, right? Okay. So step 3 is done. Step 4, that was our add and subtract step. Okay? Okay? Logan, which way do you want to move the variables? You want to move them to the left or you want to move them to the right? To the right? Okay. If I move them to the right, what do I have to do in order to do that? Subtract what? Well, what's the variable on the left side? We're moving it to the right. What's the variable on the left side? Just x? 2x. So what would I have to subtract? 2x on both sides, right? Yeah, right? So let's go ahead and let's subtract 2x on both sides. Because that means that's gone, right? What do I get on the left side? I get -7. What do I get on the right side? Just 2? No x? Right? Uh-oh. I get this. Ruh-roh. What's wrong? There's no variable. So what? Why is it a no solution, Jake? Nope. 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 Alright? Now, we're going to pause this one for a moment. Okay? And I want to go to number 2. Okay? We'll come back and we'll finish off number 1, but I want to show you the difference in number 2. What's up, sister friend? Nope. Because if you got 2 pencils and I take 2 pencils away, you got no pencils left. Right? Yeah, no, the math is done right. Okay? It's just it's kind of the point of today's lesson. Okay? All right, so let's do number 2. Okay? Let's reset with number 2. All right? Okay? All right? So, do I have a parentheses that I need to clear? Yeah, what am I going to multiply into that parentheses? I'm going to multiply the negative sign into that parentheses. Okay? So then that's going to give me 6 minus 2 plus x equals x plus 4. Right? So step 1, done. Step 2, any fractions to clear? No fractions. Step 3, any like terms to combine? Yeah? I can do these 2, right? Right? So that's going to give me x, then plus 4 equals x plus 4. Now, which way do you want variables to go? Left or right? Right? Okay. So if I want my variables to go to the right, how am I going to make that? How am I going to make this one move? Subtract x from both sides? Yeah. And that gives me 4 equals, 4. Ruh-roh. 2 ruh-rohs in a row. Looking at those 2, are they the same? Why not? Nora? So the left one, number 1, has a false statement without variables. Okay? The right one is a true statement without variables. Okay? So they're not both solutions, Jake. Okay? Okay? Because the left one, false statement, so because that's a false statement without variables, then our answer here on this one is no solution. Over here on this side, we had a true statement without variables. That means that this one is infinite solutions. So a false statement without variables. Now this should be the next one down here. If a variable disappears and the statement is false, I have this on my If a variable disappears and the statement is false, then your solution, your answer that you give us is no solution. If the variable disappears and the statement is true, then your solution is all of them. You could put inf.sol. There's more there. Okay? You could also put all real numbers. Okay? You could put, I go to infinite solutions for all real numbers. Now, I will tell you this. For the no solution one, can you put 0 as an answer? Why not? Why can't you put 0 as an answer? Yeah, think back which one it was. Have we ever gotten 0 as an answer? Yeah. So can we put 0 as an answer for no solution? No. Why not? The answer is no, Jake. Okay? You can't put 0 as an answer. Why? Is 0 a number? That means it's a solution then, right? So if there's no solutions, that means no numbers, means I can't put 0. Okay? No solution means no number can get put into that equation to make it be true. Okay? All real numbers or infinite solutions means doesn't matter what number you put into that one, it's going to be true. And that's the difference. Okay? What I'd like you to do now is I'd like you to do numbers 3 and hidden back here 4. So in my first one, I'm going to distribute in 2/3 into both of those. Okay? So 2 times 6 is 12, divided by 3 is 4. 2 times 9 is 18, divided by 3 is 6. Then, on the other side, I got to take this 2, and I got to distribute it in. Okay? 2 times 2 is 4. 2 times 3 is 6. Okay? Let's take our variables to the left side, which gives me then 6 equals 6. Is that a true statement? Is that a false statement? Or do I need to go on? The true statement, right? Right? So if it's a true statement, that means infinite solutions are all real numbers. In this one, I'm going to multiply by 10 in all 4 spots. If I multiply 3 times 10, that gets me 30. Divided by 2 is 15. That's 15x. 2 times 10 is 20. Divided by 5 is 4. 10 times x is 10x. 19 times 10 is 100. That. Which way do we want variables to go? Left. Okay. So that gives me 5x minus 4 equals negative 190. If variables went to the left, numbers, excuse me, have to go to the right. So we're going to have to add 4. And lastly, divide both sides by 5. Every single one of your problems is not going to be an infinite solutions or a real solution or a no solution case. We still have the 5 steps to follow. Okay? Yeah? So, you got E6 to work on from yesterday, if you haven't done that one yet. And then I'm also going to hand out E7.